This video we're going to do some finding the domain of a function. Okay, there's two types of functions that are crucial in finding the domain because there's a computational involved, and it's going to be the square root function and the rational functions or divisions, right? Division of polynomials or division of anything. Okay, um, and then a combination of those. Now, in more advanced classes, you'll find domains of logarithmic functions and piecewise functions and other types of functions. Okay, so for this, we have to calculate certain behaviors. So g of x equals x over x squared minus 16. Now this is a fraction, right? So for a fraction, what you have to worry about is the denominator. The denominator cannot be equal to 0, okay? So usually what I tell my students is take the denominator and create an equation with precisely that. Say x squared minus 16 cannot be equal to 0. So solve for that equation. Now, there could be examples where this is a quadratic, where you have to use the quadratic formula or difference of squares, factorization. You can do that now since b, right, the x variable is not present, then you can just solve like you will solve for x. You will add 16 on both sides, and you will take the square root. And when you take the square root, it's always plus or minus. So it's going to be plus or minus 4. So that means that plus or minus 4 will give you 0 in the denominator. Now notice that 0 can give you 0 in the numerator, but that does not affect my domain. Okay, it's only on the denominator. Now in interval notation, so the domain in interval notation will be everything except those two values. You're going to go from minus infinity to minus 4, union minus 4 to 4, union 4 to infinity. Now remember, parentheses means it's not included, so I'm not including those values by writing a parentheses. And that will be your answer for that one. In terms for a set, and this is just for knowledge base, okay? If you want to write it like that on the quiz or the test, that's fine with me. For the public, if I wanted to write as a set, you will write, well, x, an element of the real numbers, then such that, usually we set colons or dash, such that x is not equal to plus or minus 4. Okay, that's also the same thing. These two sets are equal. Okay, now in terms of capital G of x, let's use a different color now. So when you have a square root, what you have to be careful is that the inside is not negative. It could be 0, but not negative, right? Because in the real numbers, you don't have negative square roots. So what I tell my students is make an equation. So 1 minus x has to be greater or equal to 0, okay? And then solve for x. Now, I would suggest you add x on both sides. So you have 1 is greater or equal than x, but usually you will read it as x being less than or equal to 1, okay? And now in terms of the domain in interval notation, okay, it will be from minus infinity to 1. You'll use a bracket because it's included, right? It's the equal sign below the inequality that will say that it's included. Now, for the set, okay, it's going to be x, an element of the reals, such that x is less or equal to 1. Okay, and that will be the same thing. Now, for this guy right here, or lady, I don't want to be accused of anything here, you will have double domains to worry about. You have to worry about inside the square root, and you have to worry about the denominator. So let's first worry about the denominator. So 3t minus 21 cannot be equal to 0. That means that 3t cannot be equal to 21. We divide by 3. That means that t cannot be equal to 7. Okay? Now let's worry about the square root. So again, t minus 4 has to be greater or equal than 0. That means that t has to be greater or equal than 4. Now notice that these two collide, right? They have an intersection, and that will be the domain of this function. So the domain will be from 4, including 4, to 7, not including 7, union 7 to infinity. Okay? Notice that we don't include 7 because t cannot be equal to 7. So it's almost like jumping that value from 4 to infinity without including 7. Now if you were to write it as a set, you will write x an element of the reals such that t is greater or equal than 4, and we use the words and, okay? T is not equal to 7, okay? And this and is the logic and, just like in computer science, and where these two statements must be true at the same time. So that will be everything in terms of a function. Now, if you have a graph, I don't have a graph here, but I'm going to make it up because I just realized that it's good to have a graph there. Where am I? Sorry. There you go. So imagine you have a graph. Okay, I'm going to make up a graph. You have your x and y coordinates. And you have a function. Let's draw a function. Okay, and let's say this value and this value here, and then you have this value and this value here. So let's say this one, we have to take care of this one as well. Okay, just bear with me. Let's say this one is 1, and let's say this one is 5. So if I were to ask you, okay, what's the domain of this function that is a graph? Well, you will have to, like I tell my students, you have to scan from left to right and see where does it start and where does it finish. So for the domain, you'll have that it starts at 1, including 1, because it's bolded, and then it finishes at 5 in x. Remember, yeah, this is only for x. Now for the range, if we're asking for the range of a graph, you will start at -1. You'll end at 2 because it's the lowest and the highest point. Okay? Now that was just it's a little bit extra. I can make another video of only these type of problems if you want. Just let me know in the comments below. If you enjoyed the video, subscribe to my channel. Don't forget to visit us at www.multival.com for more information. Thank you.